So we are going to solve question number 2 from specimen paper 2, 2022. First part of the question, define acceleration. You can define acceleration as rate of change of velocity and you can write the formula as well. Part B, a ball is kicked from a horizontal ground towards a vertical wall as shown in the figure. The horizontal distance between the initial position of the ball and the base of the wall is 24 meters. Horizontal distance. So I will keep labeling everything on the diagram itself with the variables. This is the horizontal displacement or the displacement in the x direction. The ball is kicked with an initial velocity v at an angle of 28 degrees. Now look carefully at v. V has been drawn at an angle of 28 degrees from the horizontal, which means v is neither the horizontal nor the vertical velocity. V in fact is the resultant velocity at which the ball has been thrown. So if I try to resolve v into its vertical and horizontal components, this is how the situation will look like. 28 degrees. Okay. The ball hits the top of the wall after a time of 1.5 seconds. So 1.5 seconds is the total time for the motion. Air resistance is negligible. Now keep this in mind, when air resistance is negligible in projectile motion, that means the horizontal motion is going to be uniform motion with uniform horizontal velocity, whereas vertical motion will be an accelerated motion with the value of acceleration equal to acceleration of free fall g. Calculate the initial horizontal component of the velocity. Now, initial horizontal component, which means Vx. We know Vx is equal to V cos theta. In this question, we do not know the value of V, which is the resultant initial velocity, though we know theta. Any other formula that we can use to find horizontal velocity? We can use the basic definition of velocity, which is rate of change of displacement, because this is a case of uniform velocity. So velocity equals total displacement over total time. We have been already given the horizontal displacement, which is 24. We already know the total time of motion, which is 1.5 seconds. So that will give us a value of meters per second. That becomes our horizontal velocity. Next part, we have to show that the initial vertical component of the velocity is 8.5 meter per second. Now, vertical component of velocity also has a formula in terms of the total resultant velocity, which is v sine theta. But again, we have not been given the value of v. We can either use the horizontal component of velocity, which we already calculated, and we rearrange the equation to find the value of v, or we can just have a look at this right angle triangle with the horizontal and the vertical velocities shown. So if this is the horizontal velocity, this is vertical velocity, this is the angle 28. If I apply the 10 ratio, 10:28, 10 is equals to opposite side over adjacent side. So my vertical component is also equal to Vx into tan theta, which is tan 28 here. So Vx was already found to be 16, 16 multiplied by 10 of 28, and it will, when calculated, it will give us a value of 8.5 meter per second. So that becomes our answer, which is exactly what was already given. So in our working, we must show all the steps. Calculate the time taken for the ball to reach its maximum height above the ground. Now let's have a look at the diagram. Maximum height above the ground, which may be some height over here. Now, since in projectile motion or motion in two dimension, we can take each of the vertical and the horizontal components separately, I'll just draw the vertical component over here, the vertical motion. So this is a vertical motion. We have to calculate the time taken to reach the maximum height. Maximum height means the vertical displacement. Now, in vertical motion, there are few variables which we already know the value for. We just now calculated the initial vertical velocity, so I will name it now uy. For upward motion, motion against gravity, we always know that the final velocity at the top is always zero. Since air resistance is negligible, we also know the acceleration will be equal to minus 9.8 meter per second square. Minus because this is motion, this is upward motion against gravity. So we have few variables for the situation. We have the initial velocity, final velocity, acceleration, and we need time. Now we have to choose an equation of motion which contains all of these variables. So either I can write that equation as v equals u plus at, which is basically the basic definition of acceleration v minus u over t. If I rearrange the equation to make t my subject, I end up getting v minus u over a, which becomes 0 minus 8.5, which was the initial vertical velocity we calculated in the previous part, divided by minus 9.8. And the answer we will get is 0.88 seconds. Now, the next part. The ball is kicked at time t equals 0. Assume that the vertical component of the velocity of the ball is positive in the upwards direction. On figure 2.2, sketch the variation with time of Vy for the time until the ball hits the wall. Okay, so we have to draw a graph for Vy versus time. This is time over here, this is V axis. Now, the question is telling us that the Vy, the vertical component of the velocity, will be positive in the upwards direction. Vertical component of the velocity will be positive when the ball is going in the upward direction. And when it falls down, it will be negative. So let's quickly think of the values that we have just now calculated. Initially, we calculated previously that the ball starts to move with an initial vertical velocity of 8.5 meter per second. We calculated it while back, initial vertical component. So which means our graph will start from time t equals 0 and Vy equals 8.5. So I'll just quickly look at the graph. Where does 8.5 lie? So these are around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares showing a value of 5 meter per second, which means that each square is zero point 0.5 meter per second. So 5, 6, 7, 8 and 8.5, this is the point which is 8.5 meter per second. This is where the graph will start from. Now, how will the graph look like? Since it's uniformly accelerated motion where acceleration is equals to g, and acceleration we know of the graph of velocity time graph is its gradient. So this will be uniform acceleration or uniform gradient graph, which means it will be a straight line. Now the vertical velocity becomes 0 exactly when the object reaches the top here. And after how much time does it reach the top? 0.88 seconds, which means this is straight line of the velocity graph will cross the x-axis or will reach 0 on the vertical axis at a time equals to 0.88 seconds. Let's look for a time value of 0.88 seconds on the x-axis. So there are zero point 0.8, there is zero point 0.8 and 1.0, a value of zero point 0.2 seconds being shown by 10 smaller squares. So how much each square shows? Zero point 0.2 divided by 10, 0.02 seconds. So zero point 0.8, 0.82, 0.84, 0.86, 0.88. This is the point on the x-axis where our graph will cross the x-axis. Now, the graph will continue till a total time of 1.5 seconds because that is the time when the ball reaches the ground. So 1. So the graph should finish here at the fifth line. Now, we have to make a line, straight line. So I will try to make a straight line which starts from 8.5 meter per second, passes the x-axis at 0.88 second and finishes up at 1.5 seconds. So this is how the graph will look like. Now, moving on, and it has to be a straight line, exactly straight line with the same gradient throughout. Moving on to the next part. Calculate the maximum height above the ground of the ball in B. Maximum height. Maximum height means they are asking us to calculate the maximum vertical displacement. Now, there are two ways of finding it. One using an equation of motion, another one using a graph. How using an equation of motion? We drew the vertical motion over here. We know the initial vertical velocity, the final vertical velocity. We know the time taken to go to the maximum height. So if I write down these variables here, I know the initial velocity, final velocity, time taken, and I'm interested in finding the displacement. So either I can use the equation S equals u plus v by 2 into t, which is total displacement is average velocity into total time, and that will give me 8.5 plus 0 divided by 2 into time, which is 0.88. Or using a graph, I can find vertical displacement for the upward motion using area under the graph. Now, which area will it be under the velocity time graph? Let's just have a look at that. Area under the graph. Since we are talking about the maximum height above the ground, it is the displacement when the ball goes up. So, this is the area for the upward motion when the velocity is in the positive direction. This is the area under the graph that we have to calculate. The maximum displacement in the upward direction. And both of these methods will give us the same value. So area under the graph will be 1 by 2 into, because it's a triangle, into 8.5 into 0.88. And the answer for maximum displacement in the upward direction will be 3.74 meters. Okay. Next part, the maximum gravitational potential energy of the ball above the ground is 22 joules, mass of the ball. So, gravitational potential energy, from previously studying work energy and power, we know it is equals to mgh. We are interested in finding the mass, so I will rearrange the equation, making mass my subject, and that leaves my equation to look like gravitational potential energy over g into h. The value of gravitational potential energy is given as 22. G is equals to 9.8. H here is the maximum vertical height, which we have calculated just previously, which is equals to 3.74. And if we do the working, the mass, we end up getting a mass of zero point 0.6 kgs. Part D. A ball of greater mass is now kicked with the same velocity, which was v, as in part B. State and explain the effect of the increased mass on the time taken by the ball to reach its maximum height. So now we had initially a lighter ball, now we have a heavier ball, and both are being kicked with the same initial velocity. So they're asking the amount of time it takes for the heavier ball, will it be the same or different than the lighter ball? So let's talk about how did we calculate the time in the first place. So I will move back to the equation where I calculated the time for the ball to reach its maximum height. This is the formula I used, which is basically nothing but an equation for acceleration. So I'm going to rewrite the equation over here to understand things better. Time taken was calculated as difference in velocity over acceleration. Now think of the two balls. If they are being kicked with the same initial velocity, which means that initial velocity for both will be same. When both the balls reach the maximum height, each of it will have the same final velocity, which will be a zero. So both will have the same final velocity as well. As these balls go up, their acceleration will be exactly the same value, which will be minus 9.8 meter per second square, or the gravitational acceleration in the opposite direction with the negative sign. So acceleration will be the same value. Now look at the formula. V, U, A, all three variables involved in the formula for t are same, which means the time calculated will also be the same for both the balls, which means the time taken to reach the maximum height is independent of the mass, and it's only dependent upon the initial velocity and the gravitational acceleration. Final velocity in any case will always be zero. So state means that we have to mention will the time be different or same, and explain means we have to give a reason. So our statement will be the time taken by both the balls will be the same. This is the statement. Explanation. Next will come the explanation, and the explanation is, since time taken to reach maximum height is independent of mass of the ball and depends only upon the initial velocity. I'm only mentioning initial velocity here as final velocity will always be zero and acceleration due to gravity will always be the same value as long as there is no air resistance. And then in bracket we can write down the formula that time is equals to v minus u divided by a. Since time taken to reach maximum height is independent of mass of the ball and depends only upon the initial velocity, therefore will be same for both balls. And that is the end of the question.